Good day to everyone. My name is Queenie Faith Murillo from TCM2K2. So now I'm going to report about quality of services. So the chapter 1 section and objectives. 6.1 QoS overview. I explain the purpose and characteristics of QoS and explain how network transmission characteristic impact quality. Describe minimum network requirements for voice, video, and data traffic. Describe the queuing algorithms used by networking devices. And for the 6.2 QoS mechanisms, I explain how networking devices implement QoS. And I describe the different QoS models and explain how QoS uses mechanisms to ensure transmission quality. So for the 6.1 QoS overview, the first discussion is the video tutorial, the purpose of QoS. QoS, what is it and why is it needed? So QoS, or quality of service, allows the network administrator to prioritize certain types of traffic over others. Video traffic and voice traffic require greater resources such as bandwidth from the network than other types of traffic. Financial transactions are time sensitive and have greater needs than an FTP transfer or web traffic, HTTP. And for the packets are buffered at the router and three priority queues have been established. High priority queue, medium priority queue, and the low priority queue. So, nakita nato diri sa chart is the voice over IP, the financial transaction, and the web page. And this diri sa tuhang sa tong chart is nagkuan ang tulo ka buok, nagdungan ang voice over IP, financial transaction, no web page. So kung magdungan na siya guys, ang kana sila tulo is naa siya high priority queue, medium priority queue, and the low priority queue. Naa siya possibility nga hinay ang dagan sa tuang data, no? Kay kuan ingana gyud basta daghan mo gamit. So for the second is prioritizing traffic. So QoS is an ever-increasing requirement of networks today thanks to new applications available to users such as voice and live video transmissions, which create higher expectations for quality delivery. So congestion occurs when multiple communication lines aggregate onto a single device such as router, and then much of that data is placed on fewer outbound interface or onto a slow interface. So when the volume of traffic is greater than what can be transported across the network, device queue, or hold the packets in memory until resources become unavailable to transmit them. So the third one is mura gyapon ang chart, no? So queuing packets causes delay because new packets cannot be transmitted until previous packets has been processed. So ang pasabot ani guys is once gani na ay packet nga bag-o nga mo transmit siya sa ato ang data, hinay gud kay siya, dili pa siya musulod ang new packet kay na pa may nag-process nga daan nga packet sa to. So it's all about data yun. So for the next one is packets will be dropped when memory fills up. So naa siya packet guys nga, example packet 1, packet 2, and packet 3. So that packet 3 is naay isa ana nga ma-drop. Okay, dili man makaya sa tong data, right? So next is the one QoS technique that can be helped with this. This problem is to classify data into multiple queues as shown in the figure to the left. is it important to note that a device should implement QoS only when it is experiencing congestion. So, for the bandwidth, congestion, delay, and jitter. Okay, wait. So, the jitter. So, for the bandwidth, guys, is bandwidth usage is the amount of data that an individual receives from a network per second. So example, naatay we have 6 cars, then ang unom ana is have a per second para makuha na to ang 6 bits, di ba? So for the network congestion causes delay, and interface experiences congestion when it presented with more traffic than it can be handled. So network congestion refers to a reduction in quality of service that causes packet loss, queuing delay, or the blocking of new connections. Typically, network congestion occurs in cases of traffic overloading when a link or network node is handling data in excess of its capacity. So for the delay or latency refers to the time it takes per packet to travel from the source of the destination. So we have fixed delay and variable delay. So for the delay or latency is network delay is a design and performance characteristic of a telecommunications network. It specifies the latency for a bit of data to travel across the network from one communication endpoint to another. It is typically measured in multiples or fractions of a second. So for the jitter, jitter is the version in delay of received packets. So it's a variance in latency, or the time delay between when a signal is transmitted and when it is received. This variance is measured of milliseconds and is described as the disruption in the normal sequence of sending data packets. So, kabalo man sa taning MS no, guys no, familiar siya kay mo neto ga kita sa ML, labi na tong gadula og ML. So, once gani moabot na sa 100 ms na tong kanis, maglag na gid siya kay daghan ga connect sa inyong connection. Muna siya ang jitter. So for the packet loss, without any QoS mechanism in place, packets are processed in the order in which they are received. When congestion occurs, network devices will drop packets. This includes time-sensitive video and audio packets. For example, when a router receives a digital audio stream for voice over IP, it must compensate of the jitter that is encountered. The mechanism that handles this function is the playout delay buffer. The playout delay buffer must buffer these packets and then play them out in a steady stream. The digital packets are later converted back to an analog audio stream. If the jitter is too large that it causes packets to be received out of the range of this buffer, the out-of-range packets are discarded and dropouts are heard in the audio. For losses as small as 1 packet, the digital signal processor or DSP interpolates what it thinks the audio should be and no problem and audible to the user. However, when jitter exceeds what the DSP can handle, audio problems are heard. In a properly designed network, voice packet loss should be 0. Network engineers use QoS mechanism to classify voice packet to 0 packet loss. So, This one is the packet loss is the loss of data package because of the congestions on a network. Packet loss occurs when the router or switch has to disregard inbound data packets due to overload until the issue is resolved. When QoS effectively in place, the steady stream of traffic is supported, meaning packets don't drop out completely. Prioritization policies dictate the type of data are pipeline accordingly and eradicate jumps within our congested network. So for the next one is the video tutorial traffic characteristics. So QoS or voice traffic and video traffic. Voice and video traffic place a greater demand on the network and two of the main reasons of QoS. There are some differences between voice and video. Voice packets do not consume a lot of resources because they are not very large and they are fairly steady. Voice traffic requires at least 30 kilobits per second of the bandwidth, no more than 1% packet loss. So mas kuan yun ang voice packet guys is dili siya mag-consume og dako. Dili siya dili ka siya maglag atong kuan ba kung voice packet atong magamit. So for the video traffic is more demanding. The packets are more bursty and greedy. It consumes a lot of more resources. Video traffic requires at least 384 kilobits per second and bandwidth with no more than 1 to 1% packet loss. So it's normal ang kuan yun ang video yung pinaka magkuanog dako o kilobits kay ang video man god is mag-consume atong tingog din kailangan na ang video kay makita biyata di ba. So tanawa atong chart is the voice og ang video dayo ra gyud sila. One way requirement sa latency is 150 ms, jitter 30 ms, loss 1% and bandwidth is the 30 to 128 kbps. Then the video is one way in requirements latency 200 to 400 ms and the 30 to 50 ms and the loss is 0.1 to 1% and the bandwidth is 384 kbps to 20 plus mbps. So for the network traffic trends, in the early 2000s, the predominant types of IP traffic were voice and data. Voice traffic has a predictable bandwidth need and known packet arrival types. Data traffic is not real-time and has an unpredictable bandwidth need. So more recently, video traffic has become increasingly important to business, communication, and operations. So, needed yun kayo ang video traffic, no? Labi na sa tong mga business nato. So, according to the Cisco Visual Networking Index or VNI, video traffic presented 67% of all traffic in 2014. By 2019, video represented 80% of all traffic. So, the type of demands that voice, video, and data traffic place on the network are very different. Dahil ragid kay sila. Kaya mas dako yun ang kan sa video kaysa voice. So, the next one is the voice. So, voice traffic is predictable and smooth. However, voice traffic is very sensitive to delay and drop packets. There is no reason to retransmit voice if packets are lost. Voice packets must receive a higher priority than other types of traffic. Cisco products use the RTP port range 16384 to 32767 to process voice traffic. Voice can tolerate a certain amount of latency, jitter, and loss without any noticeable effects. Latency should be no more than 150 ms. Jitter should be no more than 30 ms. So voice packet loss should not exceed 1%. So for the video is, without QoS and significant amount of extra bandwidth capacity, video quality typically degrades. The picture appears blurry, jog, or the slow motions. The audio portion may become unsynchronized with the video. So, video traffic characteristics. Video rusty, greedy, drop delay sensitive, UDP priority, one-way requirements, the latency, jitter, loss, and bandwidth. So, with the video guys, tabi naghinay atong MS, mag-blurry yun siya. Dili na to siya dalit suma kanang matinaw bitaw, nga na magulat yun ta kay daghan ga connect sa connections. Ga ilog mangguna ga ilog. So for the next one is data. So the data is more application use either TCP or UDP. Unlike UDP or TCP performs error recovery. Data application that have no tolerance for data loss, such as email and web page, use TCP to ensure packets will be resent in the event they are lost. Some TCP applications, such as FTP, can be very greedy, consuming a large portion of network capacity. Although data traffic is relatively insensitive to drops and delays compared to voice and video, a network administrator still needs to consider the quality of the user experience. Two factors that need to be determined. Does the data come from the interactive application? Is the data mentioned critical? So, for the second one is the FIFO queuing. You know what is FIFO? The FIFO guys is the first in and the first out. Muna ang meaning sa FIFO. FIFO. So, if you look at the queuing strategies for QoS, FIFO queuing or first in first out queuing is basically the absence of QoS. Packets that enter the router will leave the router in the same order. Compare with fair queuing or WFQ and packets that come into the router then classified and prioritized based on the classification. A newer form of queued fair queuing is class-based queued fair queuing. In order to guarantee that voice traffic is prioritized to the point there is no drops, low latency queuing can be used with a BWFQ to prioritize voice packets above all else. So, queuing overview. The QoS policy implemented when a network administrator becomes active when congestion occurs on the link. Queuing is a congestion management tool that can buffer, prioritize, and, if required, reorder packets before being transmitted to the destination. This course will focus on following queuing algorithms. First in, first out, or FIFO. So, with that fair queuing, WFQ. Class-based with that fair queuing, CBWFQ. So, low latency queuing, LLQ. So, I will explain what is first in and first out. So, for the first in and first out, packets enter and exit the queuing in the exact same order. And for the fair queuing is a hatching technique divides flow into distinct queues with determining how many packets are served at once. set IP precedence and the SCP value to define width. So for the next is CBWFQ is a scheduling mechanism used to provide a minimum bandwidth guarantee to traffic classes during times of network congestion at an interface. Each of the CBWFQ queues is assigned a width and the packets are served from the queues based upon the width of the queue. So low latency queuing MQC is used to classify traffic. Classified traffic is routed to the one tree queue is priority receive and bandwidth. So first in first out. So FIFO queuing, also known as first come first serve. So queuing involves buffering and forwarding of packets in order of arrival. FIFO has no concept of priority or classes of traffic and consequently makes no decision about packet priority. There is one queue at all packets are created equally. So when FIFO is used, important or time-sensitive traffic can be dropped with congestion occurs on the router or switch interface. With no other queuing strategies are configured, FIFO is used on certain interfaces at E1 2.048 Mbps and below. F is effective for large links and have little delay and minimum congestions. If your link has very little congestion, FIFO queuing will be only queuing you need to use. So for the Vinted Fair queuing, WFQ is an automated scheduling method that provides fair bandwidth allocation to all network traffic. WFQ applies priority or width to identified traffic and classifies into conversation or flows. That's itong giingon ako, guys, ako lang to siyang summary. So, for the next one is the CBWFQ. So, that's the WFQ. Extend the standard WFQ is functionally to provide support for user-defined traffic classes. You define traffic classes based on much criteria including protocols, ACLs, and input interface. When a class has been defined according to its much criteria, you can assign it characteristics. Characterize a class you assign is bandwidth, width, and maximum packet limit. The bandwidth assigned to a class is the guaranteed bandwidth delivered to class during congestions. So the packets that match a criteria for class constitute the traffic for that class. FIFO queue is reserved for each class, and traffic belonging to the class is directed to the queue. So the low latency queuing, or LLQ. The LLQ feature brings strict priority queuing, or PQ, to CBWFQ, which reduces jitter in voice conversations. See that figure to the left. Duksa kani siya ang example. Strict PQ allows delay-sensitive data such as voice to be sent before packet in other queues. Without LLQ or CBWFQ provides WFQ based on defined classes with no strict priority queue available to real-time traffic. All packets are reserved freely based on width. This scheme poses problems for voice traffic that is largely intolerant of delay. With LLQ, delay-sensitive data is sent first before packets in other queues are treated. LLQ allows delay-sensitive data such as voice to be sent at first treatment. So, QoS mechanism. So, for this one is the integrated services example na nato sa models. So, Because packets are delivered on a best effort basis, the best effort model is not really an implement of QS. So the integrated devices model or InServe model provide a very high degree of QS to IP packets will guarantee delivery. It uses a signaling process known as RSVP or Resource Reservation Protocol. The differentiated services model or the DIFServe model is a highly scalable and flexible implementation of QoS. It works off manually configured traffic classes which need to be configured on routers throughout the network. So, select an appropriate QoS policy model. So, here are the implement QoS. So, model is the best effort model, integrated services or InServe, and differentiated services or DIFServe. Description, not really an implement as QoS is not implicitly configured or when is not required. Provides very high QoS to IP packets with guaranteed delivery. It defines a signaling process for application to signal to the network that they require special QoS for a period that the bandwidth should be reserved. However, InServe can severely limit the scalability of a network, provide high, and for the DIFServe is provide high scalability and flexibility in implementing QoS. Network devices recognize traffic classes and provide different levels of QoS to different traffic classes. So how can QoS be implemented in a network? The three models to implement QoS are this: best effort model, integrated model, and the differentiated model services. So the table in the figure to the left summarize these three models. QoS. So matanong kung ibasa guys. QoS implemented in a network using either or both of these. InServe provided highest guarantee of QoS but is source intensive, and DIFServe less resource intensive and more scalable. So for the best effort is the less commonly used model and is the most simplistic by far. This model doesn't use QoS prioritization and means that all packets are valued equally, receiving the same priority over the network. Best effort is mostly used as a default model whereby networks have not yet configured any QoS policies. So, the basic design of the internet, which is still applicable today, provides for best effort packet delivery and provides no guarantees. The best effort model treats all network packets the same way. Without QoS, the network cannot tell the difference between packets. A voice call will be treated the same as an email with a digital photograph attached. The best effort model is similar in concept to sending a letter using standard postal mail. All letters are treated the same and in some cases will never arrive. So the integrated device, the needs of real-time applications such as remote video, multimedia conferencing, visualization, and virtual reality motivated the development of the InServe architecture model in 1994. InServe provides a way to deliver end-to-end QoS that real-time application require by implicitly managing network resources to provide QoS to specific user packet streams. It uses resource reservation at an admission control mechanism as building blocks in establish and maintain QoS. InServe uses a connection-oriented approach inherited from telephony network design. So here the chart, end-to-end signaling, the QoS aware node, padulong siya sa aware node. with the IP backbone, dynamic resource reservation. So, the dynamic resource reservation, guys, is nag-connect siya sa yung tulo ka buka no IP backbone. Para siguro kuan dili siya tag siya nag-connect kung more siya one way ra siya, one way. Nag-connect ang dynamic resource sa tulo ka kuan one way din. Murag din siya. Nag-connect din siya sa uban. So, for the integrated services content, in the interserve model, the application requests a specific kind of service from the network before sending the data. The application informs that network of its traffic profile and requests a particular kind of service that encompass its bandwidth and delay requirements. InServ uses the resource in reservations protocol to signal the QoS needs of the application traffic along services in the end-to-end path through the network. If the network devices along the path can reserve unnecessary bandwidth, the originating application can begin transmitting, otherwise no data is sent. Kaniding pula guys is kuan siya, wala siya ni send, wala siya ni send sa QoS1 and sa QoS2. So the differentiated devices is the differentiated devices of QoS model specifies a simple and scalable mechanism for classifying and managing network traffic, provides QoS guarantees or modern IP networks. Their serving can provide low latency guaranteed device to critical network traffic such as voice or video. The DiffServ design overcomes the limitation of both and best effort and intermodal. DiffServ can provide an almost guaranteed QoS while still being cost effective and scalable. So, InServ is an end-to-end QoS strategy because it cannot enforce an end-to-end guarantees. However, it is a more scalable approach to implementing QoS. If the figure to the left announces forwards traffic to a router, the router classifies the flows into aggregates and provides the appropriate QoS policy for the classes. DiffServ enforces and applies QoS mechanisms on a hop-by-hop basis, uniformly applying global meaning to each traffic class to provide both flexibility and scalability. DiffServ provides network traffic into classes based on business requirements. Each class can then be assigned different level of services. So for the differentiate device services, arguably the most commonly used QoS model. DiffServ works by assigning value to each traffic type. Administrators set a DSCP or differentiated services code point value ranging from 0 to 63 for each traffic type for classify it according to priority and group traffic. According to traffic classes, thesis, these values can be allocated in relevant headers. Data with the DSCP value will take precedence over other data sets and reach their intended destination without delay or disruption. For the implementation or techniques of sequence, QoS implementation tools can be categorized into three main categories: classification and marking tools, congestion avoidance tools, and congestion managing tools. So the session traffic is classified into different priority groupings and packets are marked. Congestion avoidance tools traffic classes are allotted network resources and some traffic may be selectively dropped, delay, and remarked to avoid congestions. So congestion management tools: during the congestion, traffic is queued to await the availability to those resources. Tools include class-based with fair queuing and low latency queuing. So for the packet loss, avoiding packet loss, is usually the result of congestion in interface. So most TCP application experiences slowdown because TCP automatically adjusts to network congestion. Some applications do not use TCP and cannot handle drops. So masyado jud ang guys na UDP kaysa TCP. So the following approaches can prevent drops in sensitive application. Increase link capacity to ease or prevent congestion. Guarantee enough bandwidth and increase buffer space to accommodate bursts of traffic from fragile flows. WFQ, CB, WFQ, and LLQ. Prevent congestion by dropping lower priority packets before congestion occurs, with randomly early detention. So, more dito siya. So, for the tools, QoS tools is network performance tools form a key role for administrators looking to monitor and prioritize network traffic more efficiently for their organization. There are several QoS tools on the market. The most popular are which we've listed below to help IT teams gain a more comprehensive view over network traffic in a real time. So there are three categories of QoS: classification tools, and I will explain these three categories later. So, ingress packets gray squares are classified and their respective IP header is marked color squares. So, to avoid congestion packets and then clicking. So, these are kaniding sa 1K. Morning para maka-avoid taog congestion or packets and then queued and forwarded out of the egress interface based on their defined QoS shaping and policy. Classification marking can be done on ingress or egress, whereas other QoS actions such as queuing and shaping are usually done on egress. So for the classification and marking, a marking has to be classified before it can have QoS policy applied to it. Classification and marking allows us to identify or mark types of packets. Classification determines the class of traffic to which packets or frames belong. Policies can be applied unless the traffic is marked. Methods of classifying traffic flows and layer 2 and 3 introduce interfaces, ACLs, and class maps. Marking requires addition of values to the packet header, and devices that receive the packet look at this field to see it if it matches a defined policy. Marking should be done as close to the source and possible, and this establishes the trust boundary. Here is the traffic marking for QoS. Internet 8.2.1Q sa 0.1 Wi-Fi. So kani ang amo ni siyang wind of bits. When we use class of service, we have 3 bits. Makaabot siya 3 bits din ko traffic in T4 TID 3 bits, environment 3 bits. So for the marking of layer, that's the onan siya guys. So let's Marking of layer 2, 8.2.1 Q is the IEEE standard support VLAN tagging at layer 2 on internet networks. When through 802.1Q 1Q is implemented, two fields are added to the internet frame and inserted following the source MAC address field as shown in the figure to the left. The 8.2.1Q standard includes a QoS prioritization scheme known as IEEE 8.2.1. The standard uses the first 3 bits in the tag control information. Identify the QoS markings. There are 3 bits allow 8 levels operative. Bisa 8 levels day guys is 3 bits ra day siya. 3 bits ra ang dapat maalaw. Even though daghan kay siya daghan kaayo siya nag-connect, but 3 bits ra siya. The PRI, FI, and the VLAN ID. 3 bits used for the QoS. Use separately. Okay. For the marking at layer, IPv4 and IPv6 specify an 8-bit field in their packet headers to mark packets. IPv4 type of service or TOS field, IPv6 traffic class field. These fields are used to carry the packets marking assigned by the QoS. Classification tools forwarding devices refers to the field that forward the packet based on a QoS policy. RFC 2474 redefines the TOS field by renaming and standing in the IPP field. The new field has 6 bits allocated for QoS called the Differentiated Services Code Point or DSCP field. These 6 bits offer a maximum of 64 possible classes of service. So for the marking at layer 3, the 64 DSCP values are organized into 3 categories. Best effort or BI default for all IP packets. The DSCP value is 0. So, kuan na yun siya kanang 0 lang yun siya ang kuan sa DSCP. So, expedited forwarding or EF, the DSCP value is 46. At layer 3, Cisco recommends that EF should only be used to mark voice packets. Assured forwarding EF uses the most significant DSCP bits to indicate queues and drop preference. As shown in the figure, the first 3 most significant bits are used to designate the class. Class 4 is the base queue and class 1 is the worst queue. The 4th and 5th most significant bits are used to designate and drop the reference. The 6th most significant bit is set to 0. So the AFXY formula shows how the AF value are calculated. So ang class 4 yun siya ang concave mo dako siya space nga na atong data. And then for the 4th and 5, there's a possibility nga naa siya ma-drop, dili siya tanan musulod sa atong data. Then for the trust boundaries, where should markings occur? Traffic should be classified and marked as close to its source as possible. This defines the trust boundaries as shown in the figure. Trusted endpoints that have the capabilities and intelligence to mark application traffic to the appropriate layer 2 COS or layer 3 DSCP values. Example of trust endpoints include IP phones, wireless access points, and video conferencing systems. Secure endpoints can have traffic marked at the layer 2 switch. Traffic can also be marked at layer 3 switches and routers. Remarking or traffic is typically necessary. For the traffic, various trust endpoints classes distribution or core 1 or aggregation. So for the first computer is dagan siya nag-connect kaysa third nga computer. So for congestion avoidance is used to track network traffic, establish the risk of congestion for different data packets, and predict congestion to enable a smoother traffic course. Congestion avoidance will allow lower priority packets to be dropped in favor of high priority ones, keeping in line with QoS policies and weighted randomly early detection (WRED). So for the shipping and policing, edits the traffic upon entrance to the network, distinguishing between time-sensitive and real-time data applications such as messaging versus voice and video. Traffic shaping works by prioritizing voice and other essential traffic such as video conferencing over less time-dependent data. Traffic shaping and policing are two mechanisms provided by the Cisco IOS QoS software to prevent congestion. Traffic shaping retains exists packets in a queue and then schedules to exist for later transmission over increments of time. The result of traffic shaping is the smooth packet output rate as shown in the figure. Shaping requires sufficient memory. Shaping is used on outbound traffic. Policing is commonly implemented by service providers to enforce a contracted customer information rate (CIR). Policing either drops or remarks excess traffic. Policing is often applied in inbound traffic. So that's all for today, and thank you for listening.